So today's lesson is about primes and factorisation. So our main objectives today are to make sure we know the first 10 prime numbers and make sure that we can break a number or any number into its prime factors. So you need to obviously know your prime numbers, know what a prime number is, and we're going to use prime factor trees to break a number down into its factors. So I hope you find this lesson helpful and that at the end of it you feel that you've learned something towards your exam. So let's get started. So we're going to begin with what a prime number is. So a prime number only has two whole factors, and factors are numbers that times together to make that number. So 5 has two whole numbers that times together to make it, and the only numbers that do that are 1 times 5. We only use whole numbers, we don't use decimals. 1 times 5 makes 5, there's nothing else, so that makes it prime. Now you need to know probably the first 7 prime numbers off by heart really, but I've just done a list here of a few more than that just so that you can get the idea of kind of what they look like and the key ones to look out for. So make sure you've got these down and make sure that you learn from 2 at least up to 13 or 17 because that will help you with some questions. So now you know what prime numbers are, why don't you try and use them in these questions? Pause the video, have a go, and then we'll go through the answers and see how you got on. So let's see how we did. Question 1. There are 3 prime numbers added to 20. What are they? 11, 7 and 2. Question 2. 2 prime numbers have a product of 21. What are they? So the word product, if you weren't sure, means multiply. So 7 times 3 makes 21. So they're your 2 numbers. Explain why the number 2 is the only even prime number. This is a tricky one, okay, because a lot of people struggle to word out why it is. So I've kind of gone with all of the even numbers would have 2 as a factor, as well as 1 and itself, which means that they haven't got 2 factors, they've got more than 2. And a prime number means you have to have only 2 factors, 1 in itself. Okay, so because it's small, that means it's the first one that is even and no other prime numbers are even. Question 4, Gemma says the sum of the first prime numbers is 18. Is she correct? No, if you actually add up the first 5 prime numbers, you get 28, not 18. So she's wrong. And we're going to go through question 5 on the next slide. So let's run through that and see how to answer that question if you did get a bit stuck. So my alarm code is made using two-digit prime numbers. The first 2 digits are a prime between 10 and 20. The second 2 digits are a prime between 30 and 40. Write down the possible options for my alarm code. So we've got primes between 10 and 20 and primes between 30 and 40. So good idea to write those down if you know them so that you can use them within the question. So these are my sets of primes. Now this might be a bit tricky to kind of visualize, so I've set it out like this. Okay, an alarm code is 4 digits, so I've got the first 2, those bluey coloured ones, that's a number between 10 and 20, a prime, and the like peachy coloured is a prime between 30 and 40. So we're going to be using the numbers that we've listed in there, but because there's lots of possible options, we're going to have to list all of them to get the marks. So we could have 11 and 31 for a 4-digit code, and we could have 11 and 37. We could have 13 and 31 and 13 and 37. And we could have 17 and 31 and 17 and 37 and so forth. So actually there's 8 possible options for the alarm code using all the numbers that it could be. So hopefully that makes sense. So why don't you try a very similar GCSE style question to the one we've just done. Pause the video and have a go. Okay, so let's see how you got on. So I would obviously write down the prime numbers between 10 and 20, and then I'd write down the prime numbers between 20 and 30. So they're my numbers, and again, it's made up of 4 different digits, and we're going to split it up. So these are all the possible options that Zoe can have for her password. Great. So let's move on to prime factors. So these are words that we should know the definitions for. So if we're not sure, a factor are numbers that goes into other numbers by multiplying. Okay, so for example, 2 times 3 makes 6. So 2 and 3 are factors of 6 because they go into that number. And prime, as we know from earlier, they're numbers that only have 1 and itself as factors. So a prime factor is combining both of these together. They're numbers that go into another number, but they are all also prime. So prime factors are factors that are prime. Kind of makes sense, doesn't it? So in the exam, you will be asked potentially either on its own as a question or as part of another question to break a number into its prime factors. And that means we're going to use trees to split the number and get prime factors at the end. I'm going to show you how to do that. And this is kind of what a prime factor tree looks like. So this is the method we're going to be using. So let's start with this question. Write 60 as a product of its prime factors. So that means we're going to split this number up by timesing until we get prime numbers at the end of the tree. Okay, so I'm going to draw 2 branches and I'm going to think of 2 numbers that multiply to make 60. So you could pick 6 times 10 because 6 times 10 makes 60. Okay, so neither of these numbers are prime. So if they're not prime, you continue with 2 more branches. And you've got to think what numbers would time to make 6. 3 times 2 makes 6. And actually, because they are prime, I'm going to stop those branches and I'm going to draw a circle around them, which means I don't need to draw any more. And then I've got 5 times 2 multiplied to make 10. And 5 and 2 are both prime. So now I've completed my tree and I've stopped. So what you need to do now you've drawn the tree, is actually all those numbers that you've circled, you need to write those out. Because if they were all multiplied together, if you type in your calculator 3 times 2 times 5 times 2, all those circled prime numbers, it will make 60. And that's the point. We split 60 into the prime numbers. Now, if you want to make it even better, you potentially could write some numbers as powers. So look at your prime factors. Are there any that are the same? We've got 2 times 2. How can we write 2 times 2 better? Using powers, we can write 2 times 2 as 2 squared. So you might even get extra marks for doing that. So if you can write it as powers, do so. Now, does it matter which way you do a factor tree? So I used 6 times 10 to make 60, but what if I wanted to use a different set of factors, like 12 times 5 or 30 times 2? Look at the different trees that I've done for 60. Do I still get the same answer? Have a look at the circled prime numbers. Yeah, I get the same answers every time. I've got 3, 2, 2, 5, 3, 2, 2, 5, 3, 2, 2 and 5. So it makes no difference if your tree is different to somebody else's tree, as long as you do it correctly. Okay. Now, why would we never use a 1 in our factor tree? Well, let's have a think. If I did this, for example, 60 times 1 makes 1. Well, that is true. But I need to carry on my tree. And if I carried on with 1s, the only things that time together to make 1 is 1. So it would just keep going on forever. And you wouldn't get anywhere. And your tree would never ever end, which is not helpful when you've got a timed exam to do. So why don't you now have a practice at completing some prime factor trees for these numbers? So green are your easier numbers, yellow a little bit more tricky, and red are like larger numbers for you to split up. And it's really good practice to have a go at this without a calculator, because it's really a good way of how to practice your factors and your multiplying. So pause the video, have a go, and see how you do. Okay, so here are your answers. I've written using powers. So if you haven't done that, make sure you write your final answer using powers just to get those extra marks. And hopefully you did okay. So final thing for today's lesson is to have a go at a GCSE style question. So this would be worth about 3 marks in an exam. So it says express 56 as the product of its prime factors. So pause the video, have a go on your own, and then we'll go through it afterwards. Right, so let's see how we did. So prime factors means we're splitting up the number using our prime factor tree to get the prime numbers at the end. So I'm going to draw a prime factor tree for 56. So 8 times 7 is 56, and then I've broken down 8 into 4 times 2, and then 4 into 2 times 2. You could have done it a different way, but that's the one I chose to do. So if I was to write out my prime factors, I've got 7 times 2 times 2 times 2, and of course we'd write the 2 times 2 times 2 as 2 cubed times 7 to finish that off and get that final mark. So I hope you found today's lesson useful, and I hope that you will join me again for another video soon. Bye!